Hello everybody, I'm Dean and this is Dean's N-Scale Trains. Today I'll be showing you an experimental software for an Arduino project that I made with my layout that brings together servos, switches, EEPROM memory, and a liquid crystal display, or an LCD, all working together to control the model railroad switches on my Santa Fe Northern layout. This system calibrates servo positions on my 13 servo-controlled switches, stores the positions permanently on an EEPROM, and operates everything with a control board here with toggle switches and real-time feedback from the LCD. I'll walk you through how it works, what each part of the software does, and show you how you can customize it for your own layout. In an earlier video in this series, I showed you how I built the hardware. The video's address is shown in the comments below if you want to take a look at it. There's a major caveat for this system. There's a hardware bug in the 16-channel servo controller that I use that causes undesirable servo movement when the controller first turns on. I haven't been able to figure this out. So far, this hasn't led to any damage to the servos or switches, I think because these small servos that I have very little power. Here's an example of one of the servos. But I can't guarantee that this might cause some damage if you integrate the system into your layout. So I'm sending this video out in the hope that someone will be able to explain the problem and give a solution. Although design and construction of the hardware for this project was easy, I've been working on the software part for over a year. In the end, I relied heavily on two artificial intelligence programs, Copilot, a program available for Microsoft, and the AI program available on the Arduino cloud platform, which can be used to develop programs. I'm hoping that you shouldn't have any problems adapting this program to your layout. I'll show you the changes you need to make to adapt the software to your model railroad layout and how to load the program and test it with an Arduino microcontroller. So let's get going. At this point, I want to briefly go through the wiring diagram as I showed in the previous video. The push button connects to digital pin 2. The LCD is hooked up as shown here. This is a conventional hookup for that. The 50K pot is what I used. That goes to analog pin 0. And the 9 single pole double throw toggles are tied into the pins as indicated up there. The important thing I want to note is I used two power supplies. One was a conventional USB 5-volt cube used in things like cell phones that plugs into the Arduino. I used a separate 5-volt power supply to power the servo controller. If I connected that to the same power supply, the power supply got overloaded and the servos did not operate correctly. Here's an example of what I'm talking about. The Arduino is powered with this cord, this power supply. The servos are controlled from this separate 5-volt power supply. Watch what happens when I turn on the power with the Arduino not there. You see, they give very erratic operation. I'm going to do the same thing with the Arduino plugged in. Turn on the power, and we still get some wiggles. And you see, this one is in the wrong position. If I cycle it, I can get it back. Here's a quick summary of the hardware for the system. I've put this down into the comments so you can read it at your leisure. So before I get into the software description, let me repeat once more about how the software works, what it does. The button is used to move between different parts of the program. The potentiometer is used as a chooser, you see now it says choose operation, operate switches. Tune switches is a second operation. Read the EEPROM values. Read the switches. Let's start with that one. You can see it puts a 1 for each one to say that it's in the standard position. If I throw this one, you see it changes it to 0. Let's try that one. Changes that position to 0. So this is a good way to make sure your wiring is correct and also to make sure your switches are set up. Let's go back into the menu. We're going to read the EEPROM. This reads the stored values for each of the switches. Switch 10, that's for the low value and the high value, for the curved and the straight positions. See, you can read all the switch values here. Now I'm going to be retuning this one, which according to our diagram is switch 6. So let's go to 6. 417, 353. Once I'm into the program, into operate, I can throw those two switches. This one I'm going to tune. So let's go back into our menu, go back into tune. And this is number 6, so I set it for 6. See, it says left crossover number 6. Now it wants me to set the pot for 400. That gives a central position. And if I were originally setting this switch up, when I had set it for 400, I would then adjust the linkage such that it sat pretty much between the zero, pretty much in the center. So it says set straight. You can see it's changing the position of the switch. I want it when it just closes. If I go too far, it stresses the switch and also sometimes gets noisy. So 415, 416. The value before was 417, but that's close enough. Set the curve. Just when it's 338, it was 353, but we'll go ahead and leave it there for now. Let's get out of that. Go to operate switches. And it has the new value. So that's what you can do with this software as it's currently written. Now that I've shown you what it will do, it's time to jump into the Arduino software. I'm just going to give you a quick overview of the Arduino system. Go to arduino.cc. There's a tremendous amount of information here and the documentation on both the hardware, the software, programming, some tutorials, etc. But now I want to download the Arduino software for your computer. Hit the software button. You want to find Arduino IDE, discover more. This stands for Arduino Integrated Development Environment. Hit the download button, choose your system, either Windows or Mac. Go ahead and download it and follow the instructions to install the program. So after you've got the program downloaded, go ahead and open it up. You see it opens up with this screen. This shows the general configuration of all Arduino programs. They start out with a setup program that runs to put in things that you have to do. And then there's a loop that runs continuously, which is usually the main part of the code. To check things out, take a look at your Arduino that's plugged in. Generally, when you buy one, it will come with a programming cord that will plug in. It's a USB programming cord that will plug into your computer. If you look at it, there may be a light blinking, an LED blinking. Often they come loaded up with a program called Blink. Go down to examples, basics. You see there's a huge number of programs here that you can try out and then go into Blink. This program just down in setup, it picks a particular pin to set up as a blinking light, and then a loop that just turns it on, waits a second, delay of 1000, waits a second, turns it off, waits a second, and then continually loops. So to load this, go to the upload button here, push it, it compiles it, and I got an error message, failed to upload, which means it did not pick out the correct port. Tools, port 8. Okay, and there it uploaded it. Now if we look over at our board, we see that the Arduino is blinking a light at a second. Let's just try to make a difference here. Let's wait for 2 seconds. We'll make that 2000 milliseconds. And change the off time to half a second, which is 500. These things over here, the // things, tells the compiler to forget about this line. This is just an information line for the programmer or the user. Let's load it again. And now you can see it's on for 2 seconds and off for half a second. So congratulations, you've just loaded your first program. Now I'm going to go into a quick introduction to the code I wrote. You can get it at this link. I'm going to put the link in comments so you don't have to write this down. It's labeled SFN operational, my version, currently October 2nd, 2025. I'm going to give you a quick rundown of the code, going through the various parts. I'm not going to go into a deep description of everything, but I will show you what parts you have to change to adapt it to your layout. Here are the various parts of a complex Arduino code, such as the one that I'm going to show you. I'll go through these individually and discuss them each. So the first part of the code has a bunch of comments, just informational things. As I said, anything that starts with a / tells the compiler to ignore the rest of the line. I've added other comments, such as here. Again, there's a / to tell it to ignore the comment. I've put in enough comments to help you as you're going through to help you to understand the code. Libraries are things that other people have written that do important parts of the code. Those are here. These include wire, which does a lot of things. Next comes EEPROM and an associated variable. That's used so we can read the EEPROM where I store values. Then there's an Adafruit program, an Adafruit servo driver program with a servo frequency, and finally some liquid crystal code so we can use the 16:2 liquid crystal display. Global variables and constants are things that are used by various parts of your subsequent code. These here, you should not change. Use these values. The button pin is 2. That's the digital input pin number 2. Pot pin A0, that's analog pot. The analog pin, that's used to read the voltage on the potentiometer. These other variables are used by later pieces of code. Then we get to global variables. This is where you start putting in things that are individual for your particular program. The servo numbers should start with servo number 1. Label your first servo number 1. And then this servo num variable, put in the maximum number of servos you have. If you got 10, put that 10, whatever. Leave these two. The pot center helps in tuning it. It tells you where to center your servo as you're setting it up. Low value and high value, you may have to change these if you can't move your switches back and forth enough. Finally, this character label switch is a dimension variable. This is what you use to label your various switches within the program. The first one, 0, is not used. Arduino multi-dimensional variables always start with 0, but I generally start with 1. These are the names that I put in for the various switches. Right crossover 1, right crossover 2, team track, industrial, etc. You have 16 characters for each of these labels, and then a couple more that down here that pieces of the program use. Don't change those. Okay, now we get down to the meat of the program, the subroutines. These are things that perform various operations. The first one is choose switch. This chooses the switch number based on the position of the potentiometer. After you choose it, you push the button to get out of here. You notice throughout the program a number of serial print lines. These I put in to help people debug it, to help me debug it when I was writing it, and also people if they're later on, if they need to debug their program. This prints things out onto the monitor, the serial monitor, which is a part of each Arduino IDE. After you go to choose switch, it goes down into tune switch, which is pretty obvious. It helps you pick the values for the straight and the curved positions of each servo. After you choose a servo, you go into tune switch. Okay, once you're in tune switch, the first thing you do is it tells you to set the pot at 400. At that point, you adjust the linkage on the switch such that the switch is approximately centered. This is very important as this is the start point for all your tuning. After that, as I demonstrated before, you tune the switch by moving the potentiometer such that the switch is in the straight position, then you push a button, and then you tune it to the curved position and push the button again. These values are stored in the EEPROM. Let me quickly go through the rest of the subroutines. Read EEPROM is pretty clear. It's what you use to print out the values that are stored on the EEPROM. Read switches, prints the value of the switches in that long line of ones and zeros. Update LCD does exactly what it says. It updates the LCD. String pad to 16 fills the LCD strings with blanks. Button press is particularly important. It continually monitors the position of the button, and when it's pushed, it tells the program that has happened and the program can continue. Validate EEPROM just does a check on the EEPROM. And then we finally get down to operate switches, which is the most important one. Obviously, this changes the position of each switch based on where the toggle switch is located. The important thing here is in this line, switch pins, you put in where the servo numbers are tied, which pin the servo numbers are tied into. Digital pins 3 through 13 are used to tie in the various servos. Then you come down to the servo map here. The first one is ignored because that's for index 0. But here you see there's a 1 and a 2 and then a -1. This tells the program that switch 1 on the digital pin 3, the toggle switch 1 on digital pin 3 operates both servo 1 and servo 2. This line just has a 3 and then 2 negative 1s. This tells it that toggle switch 2, tied on pin D4, operates servo 3, and then continuing gone down. When you get to toggle switch 5, it operates digital pin and servo 6 and 7, and the rest operate each servo. So it's very important that you set this up correctly. When the program first starts, as I mentioned before, it runs through the setup routine, finds the setup routine and runs it. This does a number of things. You shouldn't really have to change anything here. Just leave it as is. After the program runs through the setup routine, it goes into loop, which is the main menu program. Okay, so now we're down into loop. The constant character label menu has these obvious labels. Gets down here to while the button is not pressed. This statement says while the button is not pressed, just cycle through here. As you vary the value on the potentiometer pin, it will go through these various labels. When you get the one you want, you push the button and then it jumps down. If you chose case 1, it goes to operate switches, case 2, tune switches, and so on. So after it runs through here, it will jump to the particular subroutine that you have chosen, and then the program does what you have chosen. So that ends the discussion of my software. I hope I've made this clear enough that if you decide to build this, you can figure things out. If not, put your questions down below in the comments and I'll try to answer them. Remember, a discussion of the hardware is in the previous video. I've got a reference to that in the comments. If you do build this servo controller, or if I've helped you in designing your own system, please let me know in the comments below. As always, I really appreciate your watching. If you like the video, give me a thumbs up and subscribe to my channel if you haven't already.